Alright, so ironically what I just did in the prior chapter, I'm going to undo. I'm just going to select the portion of the globe I'm really interested in animating. I'm not going to work with this part here yet and waste any cycles on number crunching there until I'm totally ready to combine it there and do my final render. So I think I'm going to use about this much in the end, or maybe this much, but I need a little bit of margin, so always make it a little bit bigger than what you really need. Let's crop to that. Image, crop to selection. And there you go. So we're going to work with this animation, and we have our 51 frames right in there. Save that one. Animation, save, and that one's number 4. Alright, so what is it we want to do? Ultimately, what we need to do is slow this down. So that means we need to have more frames. And there's 2 ways we can do that in Dog Waffle. One is we go to the animation, go to the frames, and then say time stretch. And that's something you see in many other programs too. It's basically saying, well, we have 2 frames, let's put one in between that's kind of half of both. It's doing a frame blending if you ask it to do so. So that's one thing that you will want to do here. And instead of the total frame count of 51, you could say let's make that twice as many, or 3 times, 4 times, whatever. You can put the number multiplier here, or you can put the exact number of frames that you want right in here. So let's say we want, I don't know, 600. Alright, and so what it's doing, let's have a look first. Let's just playing it. And if you look at it really well, you see a lot of, what's that the right word for that? Strobing. It's like a strobing effect. It's almost like a caterpillar that's roping down there and sliding down. And so what you see, what's happening is that, like for instance, if I'm on one of these frames, the one before might be a little bit blurry and even more blurry, and then it gets clear again as I click backwards or forwards. And because basically it picks one frame that we had in the original animation, and then it gradually fades it out over 5 or 6 frames, and then 5 or 6 steps. These are tween frames, and then gradually it will bring in the next one. So you can see that very slowly if you scrub through that. And when you play it at normal speed at 30 frames a second, it's just an obnoxious side effect. We call that strobing or whatever. We call it crap. So what we need to do is find a better way. Now sometimes the trick is to not go straight to the 600 frame count, so not 10 times as many as initial, maybe just 2 times or 3 times, and then another 2 times, and then another 3 times or whatnot. But it's still going to have strobing. Trust me, this is not something that's easy to get rid of simply by working it in a couple of sequences. So a better way to do that is to use the motion prediction, and basically to say, wait a second here. What we could do is put a little box here, right? Let me see if I can draw a little box, and I'm going to use a very small cursor, and I'm going to say let's draw a little box around here, and then see if we can determine where the content inside that box is moving. This is what we call a motion prediction tool, right, or a motion tracker. And we do another box that's here, and another one here, and actually, you know, not in a messed way. We will have them in a very nice layout. Let me try to do this like this. So it's going to be a rectangular array of tracking devices, motion trackers on every single one of these. And yeah, it's not overlapping, it's really adjacent side by side. But as this moves from one frame to the next, we want each of these little blocks to kind of track where they're going, and then do a morph or a transition, moving these pixels across from one frame to the next. That's motion prediction. It's really a set of many motion trackers on a large number of elements inside your big picture here. So let's do that. Let's start with a clean image. Open number 4. And with number 4, let's go into the filter called, under the animated category, called motion prediction module. You've heard me talk about this one more often than not. So what we'll do here is, first of all, let's go to a dry run. We'll test some things here. Let's use the default parameters. This might just be our lucky day. Let's go and run go. And there we go. This doesn't show too much in roping. Look at that. It's going really fast. You gotta really look at that. So let's go a little bit more, maybe 5 times, and see if there's any strobing at that level. Oh, looks pretty decent. Alright, let's go maybe 8 times. Oh, you know what? Let's make it, what do we have? Initially we have 50 frames or 51-ish, and we really wanted about 10 times as much, so we need 500 frames. Maybe here we cannot say how many frames we get, but we can say how many tweens we need, and the algorithm has a little bit of fuzzy edges and stuff, so in the end it's going to be approximate. Maybe we need 600, right? And if we really need 600, let's say we need a few more. let's give it 650, right? And then that way we have a nice, whoa, that's really too many though. No, we don't need 31,000 frames, because this is not the number of frames. Remember, this is the number of tweens. Alright, so let's be careful here. If we do 11 times, what do we get? 540. Not quite there yet. Let's do 13 times. Alright, that's better. 638 frames. Let's go with that. Alright, now here we barely see any strobing. There's a little bit on the edge, and that's a known limitation of our algorithm. It doesn't do the job inside the edges. These are edge of water conditions. But one thing you can see, remember what I showed you when we were looking at little squares that are motion trackers? We can actually see them right there. If you change the grid spacing, you can see how fine or how coarse these motion trackers are laid out. Each one of these little squares is a motion tracker. Where is it going to look? How far is it going to look for where that element moved? Well, that's going to be controlled by the search distance. So you have little arrows here, the center of which indicates if it's the center of the motion tracker, that's how far off it's going to look in all directions. And so you don't need to go very far, because this is moving fairly slowly to begin with. Right? So you can actually save time and also improve the quality by keeping it fairly tidy here. Let's go back to 12, and I think the default is about 40 or so. Let's keep it around there. Let's do another go at that. Looks fairly decent. I think we can go with that. Now, if it wasn't, if there were still some areas, and you will probably see some areas at times that still do a little bit of strobing, and especially if you have a much larger map and things are moving faster. Here it's moving. Oh yeah, see, there is one right there. That one's strobing a little bit as it's moving fast right in front of the globe. That's the part where it's moving the fastest. Did you catch it? Let's play it again. Look around here. It's okay here, but there, these parts, there you go. There, see that strobing effect here? Alright, that we need to clean. And this is what we do. First of all, we can try a refinement pass and leave it at 1 and see what that does. Maybe that works better. Now, that's going to take more time, right? Number crunching galore. We're probably doing about 3 or 4 million calculations per pixel here. Now it's still doing a little bit of strobing, so let's go stop that and see if we can do refinement optimization at 0. That one might just be what we need. Difficult to say though, because you know, it's cranking along here, and every once in a while we'll see a little update. So let's keep our eyes around this area here and see if we see any sort of distortion, any sort of anomalies, any sort of yuckiness. Well, no, so far so good. Touch on wood, touch on my head. Alright, looks like we've got that one. But if we didn't, one more thing you could do is say, well, let's not do 1 frame, let's do 5 frames averaging and see if that helps us predict exactly where each of these elements move. And then stochastic 15 is an averaging over 15 frames. That might be a killer for your system if you're not on an i7 or otherwise, you know, 8-core machine, and you really want to have a high-end system here. But you know, give it a try, and I'm going to just run that test right here, and that works fine. Alright, so what I'm going to do now is uncheck the dry run. We're pretty much ready to go do this. Right, so now you're comparing the time it took me to prepare this. What is it, about 4 or 5 minutes? The time it took me to prepare this and experiment with that until I got the right parameters, most likely I'm done in another 2 minutes, right? So we're talking about 6 minutes for something that, you know, if you had to re-render that in your 3D program, it would take you a couple of hours. Right? That's really the message here. Alright, so one more thing that we'll need to do though is, like as I mentioned, the borders are not, the edges are not properly handled. Those are outside of the scope of our algorithm, and so we will need to crop that off. And then after that we can perhaps expand additional edges to the side, and that's exactly what we're about to do right now here. So I think this one's done. We can close that. Let's go back to 100% zoom and see what we got so far. Looking good. There's a little bit of yuckiness on the edges. Let's zoom in on that so we can see it better. Yep, see that? That's totally expected. See how it's a little bit of a strobing effect there and roping? That's totally expected inside along the edges. You can see that perhaps here. Well, no, that's black on black. It's not going to show much there. This side is good too because we got enough margin, but on the right side here is good. So only the bottom is showing some yuckiness. Still, what we need to do is to crop that. Alright, so I'm going to go and select my rectangular mask again. Let's zoom in a little bit. Remember, that's Shift and Control and then the right button on the mouse. So Shift and Control to zoom in and out with the right button, and Shift Control and then drag around with the left button. Alright, so I'm going to give me a little bit of margin here on left and then go down. And so now we can say, maybe we need, no, we do need the right edge there of the planet as well. There you go. So we have basically selected an area around it that we don't want. This selection on the inside is what we want to keep. Let's image and crop to that selection. And then we do whoop-de-doo what we've done before, which is to add to that frame, right? So we will change the image size. That will be here on the image size. And background color is not black. Let's do this in a better way. Let's make sure background color is black. By the way, if this were not black, how do you make sure it is black or it is that same color that we're going to expand? Well, you grab the turkey baster here, or the color picker, and you right click on it, so it picks that color into the secondary color. And now we have that, so we can go to the image resize or image size, and we can say we're going to keep the lower left corner where it is. So if we're making any additional margins there and adding stuff to it, it will be to the upper side and to the right side. Alright, so let's say, how wide do we do this? Our boss tells us 800 pixels wide, and on the height we need 320. Right. And there we are. Look at that. There we are. All done. So we can play this, and isn't that beautiful? Now maybe that's still too fast. Right? Okay, so let's do one more. Hey, this is going to be really easy now. So let's go filter, animated, motion prediction module one more time. Let's do a quick dry run. This time we'll say just twice as many, right? And probably don't need any of these refinement passes, just moving slow enough at this point. But let's go a test, and it's going to give us 1271 frames. So this ought to look really nice at that point. And if you really need perfection, then you can always go a little bit more and say without the stochastics, but with the refinement pass, why not? It's going to be about the same in terms of the impact. And actually, it takes a little bit longer for the refinement pass. So let's go stop that. Let's do a stochastic without, in fact, and do one more test that way. That's the fastest one here. Wait, I'm still on refinement. Let's uncheck that. There you go. That's better. Alright, so we see this. Perfect. Alright, so let's go dry run off, and we are ready to go. Alright, so here, I think I can hold my breath. That's so fast. Look at that. And you can actually see here the count at the top of the window. It's showing which frame it's on. 340, 60, 80, 400. It's going to go to 1200 total. Right now the frame count is 638. It goes from 0 to 637. But once we're done, we're going to have about twice as many. So it's going to go to about, I'd say about 1200 something. Alright, I'm going to pause this for a second and come back when we are almost done. And we're back. And so at this time, look at that. We have 1271 frames. 1270 frames, and we can easily see the first one. By the way, you're gonna want to toss. Okay, that one usually wraps around from the last one here. You might actually keep it. It doesn't necessarily look bad, but it's a jump there, right? It looks like we're still in the process here, so we can toss this one, and we probably are good here. Let's go play that. Oh, isn't that beautiful? We'll zoom in a little bit. We get a closer look. Look at that, and we did not have to re-render that in 3D. Okay, so there's one more thing we need to do, and that's to change the background. We do need some bright sun, perhaps, or little stars, maybe a moon, and so on, nebula. Let's see what we can do for that.